Hello students, welcome to my channel. In this class, I am going to teach you some theorems from complex analysis. Let us start the topic. Fundamental theorem of algebra. The statement is every polynomial of a degree greater than equal to 1 has at least one zero in C. That we have to establish. Proof. Let f of z be a polynomial of degree greater than equals to 1. We have to prove that f of z has at least one zero in C. So we are taking f of z is a polynomial of degree greater than equal to 1. We have to prove that f of z has at least one zero in C. In order to prove this theorem, let us use method of contradiction. So in order to prove this theorem, let us use method of contradiction. If possible, let us suppose that f of z has no zero in C. No zero in C. What does it mean? It means f of z not is equal to 0 for all z belongs to C. Here f of z is a polynomial. So f of z is analytic for all z belongs to C except at z is equal to infinity. Then so f of z is an entire function. This implies 1 by f of z is also an entire function. When z tends to infinity, then f of z also tends to infinity. 1 by f of z tends to 0 when z tends to infinity. This implies 1 by f of z is a bounded function. Now 1 by f of z. Now 1 by f of z, entire function, also bounded function. Now by Liouville's theorem, 1 by f of z is the constant. Implies 1 by f of z. This implies 1 by f of z is a constant function by Liouville's theorem. So this implies f of z is also a constant function. This implies degree of f of z is 0, which is a contradiction. Hence, the polynomial f of z of degree greater than equals to 1 has at least 1 0. In C, proved. With this, our first theorem is now proved. Let us proceed to prove the next theorem. So, our next topic is Cauchy's inequality. If f of z be analytic inside and on a circle C with the center z0 and radius r, and f of z mod lesser equal to m on C, then fn of z0 mod lesser equal to n factorial m by r to the power n. Proof. Given C is a circle with the center at z0 and a radius r, then we have z minus z0 is equal to r. We know fn of z0 is equal to n factorial by 2 pi I. Integration over C f of z dz by z minus z0 to the power n plus 1. So this implies fn of z0 mod is equal to n by n factorial by 2 pi I mod integration over C mod of f of z by z minus z0 to the power n plus 1 dz, which is equal to less or equal to n factorial by 2 pi integration over C. This is capital M, this is r to the power n plus 1 dz, which is less or equal to n factorial by 2 pi m by r to the power n plus 1, then integration over C dz. So less or equal to, which is equals to n factorial by 2 pi m by r to the power n plus 1. This is 2 pi r, because the circumference of the circle C with radius r is 2 pi r. So this is equals to n factorial m r to the power n. So we get Fn of z0 mod is equal to n factorial m r to the power n. So the Cauchy's inequality f of z be analytic inside a circle with the center z0 and radius r, and f of z modulus r equal to on c, then Fn of z0 modulus r equal to n factorial m by r to the power n. And we are getting the result here. Fn of z0 less or equal to n factorial m by r to the power n. Proved. So we have proved the inequality. With this, the topic for today class is completed. I shall meet you with a new topic in my next class. Till then, goodbye.